So this question says, are the triangles similar? And then it says, if they are, state which postulate you used and write a similarity statement. All right, so in this first one right here, the first thing I need to do is figure out which pieces go together so that I know which pieces to set up in my ratios. Actually, I guess before we even do that, we should look to see if we have enough information to prove that the triangles are similar. On this one, I know all three sides. And on this one, I know all three sides. So I could use side, side, side similarity. In fact, let's write up here what our three postulates are. Side, 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 angle, angle, and side, angle, side. Okay, so on this one, I can use side, side, side. But to use side, 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 you have to check all your ratios. So I know that 5 is the smallest side of this triangle, and I know that 10 is the smallest side of this triangle. So I know that 5 and 10 are going to have to go together. All right, and then the medium side of this triangle is 6. And there's not a medium side over here because these two numbers are the same. Well, if these two numbers are the same and these two numbers aren't, I have a feeling our ratios aren't going to work out very nicely. But we can go ahead and check them. So we'll go ahead and stick that one, the 6, with this side, and we'll have the 7 with the 14. All right, so I've got a 6 with a 14, and then I've got a 7 with a 14. All right, so 5 over 10 reduces to 1 over 2. 6 over 14, math enter, reduces to 3 over 7. Are these two ratios the same? If they're not the same, then these two triangles are not similar. So right here, are the triangles similar? I would say no, they are not similar. All right, let's look at this one down here. This one down here, first let's decide if I have enough information to prove that they're similar. I see that I have one side of this triangle and another side of this triangle. And then if I'm looking at the whole triangle, the big one, I see I have this side and this side. And one other thing I see is that they both have the same angle B. All right, so one thing that we learned in an earlier video is that if you have two triangles that are inside of each other like this, there are lots of different ways that you can set up these ratios to check to see if they're proportional. You could do 5 over 4 and 3 over 2, like going across the triangle, or you could go down the sides, 5 over 3 and 4 over 2. Either one works. Let's go down the sides. Let me just switch colors so we have something a little different. All right, so if I do 5 over 3, and then on the other side I do 4 over 2. Well, 5 over 3 already is in reduced form. That's as low as it can go. And 4 over 2 reduces to 2 over 1. Are 5 over 3 and 2 over 1 the same? No, they're not the same, which means these two triangles are also not similar. Well, hopefully we find one that is similar. All right, last one. This one, we're going to have to use some information that we know in order to work this out. Like, I see that these lines are parallel. If this line is parallel to this line, and I have this transversal cutting through, I know that this angle and this angle are equal because they're alternate interior angles. All right, I'm going to back the transversal out, but I'm going to leave the alternate interior angles in. All right, and then I'm going to grab a different color. If I look at this transversal, I have this angle and this angle are alternate interior angles. And then guess what else I have? I also have this angle and this angle, 3, 2, 3, because these two angles are vertical. So I actually know all three angles about both of these triangles. So I can say that these are similar by angle, angle. It's okay that I have all three. I only needed 2, but it's okay to have more. All right, so I can say that these triangles are similar by angle, angle. And now it says to write a similarity statement. All right, so if I call this first triangle up here X, Y, Z. is similar to blank. Well, X is my blue angle, my vertical angle, so if that's going to go first here, it's going to have to go first over here too. Y is my orange angle. My orange angle down here is W, so W needs to go second. And Z is last. Z is my light blue angle, and my light blue angle down here is V. So this would be the answer to that third problem. I gave the postulate that I used and the similarity statement.